Hi. Last week's video, we learned how to do equations of a straight line using a table. In this video, we're going to learn how to do them a little bit quicker. And we're going to be using the gradient that we practiced last week. So I'm going to go through some examples and then have a go at the questions on Sparks. Thanks. Okay, so we've got four equations here that we're asked to draw lines of, and they're in the format that we're used to, which is y equals, and then 2x minus 1, y equals 3x minus 4, etc. Now we could do tables of values of these for all our x values from -2 to 3, but there is a quicker way to draw these. And I've made some notes just on the bottom of the page here. So in these y equals 2x minus 1 example, the number next to the x is always the gradient of the line. It's how steep the line is. So this is going to have a gradient of 2, which means every time we move 1 square to the right, we're going to move 2 up. The other number, the number that's on its own, is the y-intercept. So this is our y-axis. So basically the number on its own is where this graph is going to pass through the y-axis. So to draw these lines, we can do them much quicker than a table of values. So our y-intercept, our number on its own is -1. And this is always our first dot. The number on its own is the first dot. So I'm going to put a dot on -1. What's going to happen then, as we go across here, we have a gradient of 2. So every time I move 1 square to the right, I have to move 2 up, because the gradients are 2. 1 square to the right, 2 up. 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 So that gives us this line plotted onto a graph. You can also go, if you move to the left, you go 1 step to the left, 2 down, 2 down. And you can see it's a straight line. And then once you've finished, all you do is you connect up the dots. So it's a much, much faster way of plotting this equation that we want. And the thing that you've got to remember is the number next to the x is always the gradient, and the number on its own is the y-intercept. So let's draw a couple more of these. We'll put these on and we'll do them together. So 3x minus 4. So the number on its own is -4. So our first dot is going to go on the y-axis at -4. Then the gradient of this line is 3, which means I move across 1, I go up 1, 2, 3. Move across 1, go up 1, 2, 3. Move across 1, go up 1, 2, 3. Move across 1, go up 1, 2, 3. When I do this, I always plot about 4 or 5 dots, and that just makes sure that I'm going to get a straight line. If you only do it with 2 dots, you can go off course quite significantly. So I always do 4 or 5 dots. There we go. That in red is the equation of 3x minus 4. I've got 2 more examples here. Just sometimes they try and trick you a little bit or put them in different formats. So here we've got y equals 4 minus 2x. Well, the number on its own is 4, and the number next to the x is -2. So our first dot is going to be at 4, and then our gradient is going to be -2. So let's plot that one. So here we go, we've got starting at 4. So our dot on its own, our number on its own, doesn't matter whether it's first or second, it's the number on its own, is 4. And our gradient is -2, which means I move across 1, I go down 2. Move across 1, I go down 2. Move across 1, go down 2. Move across 1, go down 2. Got my 5 dots. I can now draw the equation of my line, which is going to sit there. So the last one here, y equals -2 plus x. If you pause the video now and have a go at that one. Right, let's plot that one. So our dot on its own, the number on its own is -2. So my first dot on the y-axis goes at -2. And then it's plus x. Now, plus x could also be written as plus 1x, because
because we don't write the 1. So that just means every time I go across 1, it's going to go up 1. So across 1, up 1, across 1, up 1, across 1, up 1, across 1, up 1. Got my 5 dots. And away we go. We can draw our final equation of a line. So that's 4 equations of a line done in about 3 minutes. It's much, much quicker than using a table of values, and it relies on your understanding that the number next to the x is always the gradient, what happens when I take one step to the right, and the number on its own is always the y-intercept where it crosses the y-axis. Now have a go at some of the practice questions. Thanks.